Welcome to the ninth part of VCAA Mathematics 2020 exam paper series. In this video, we will present exam paper 2 section B question 2, which consists of 6 parts. Most students did well on part A and part D. Apart from part B, where about half of the students had full score. However, students scored poorly on the rest of parts.
Hello, Math Champions! I'm Dr. Chen. If you want to improve your math skills and understanding so that you gain confidence, enjoy math more, and get better results, click subscribe and hit the notification button so that you don't miss anything.
Welcome to this VCAA Mathematics exam paper series. This is section B of 2020 exam 2 paper. There are total 5 extended response questions in section B. In this video, I will present you the second extended response question. In question 2, the area of parkland has a river running through it. The diagram is shown below. The north bank of the river is modeled by the function f1 of x equals 20 cosine pi x over 100 plus 40. The south bank of the river is modeled by the function f2 of x equals 20 cosine pi x over 100 plus 30. The domain of both functions is over the closed interval from 0 to 200. The horizontal axis points east and the vertical axis points north. All distances are measured in meters. A swimmer always starts at point P, which has coordinates 50, 30. Assume that no movement of water in the river affects the motion or path of the swimmer, which is always a straight line. There are 6 parts in this question. In part A, the swimmer swims north from point P. Part A of this question is to find the distance that the swimmer needs to swim to get to the north bank of the river. In part B, the swimmer swims east from point P, and it is to find the distance that the swimmer needs to swim to get to the north bank of the river. Part C is to find the minimum distance that the swimmer swims from point P to the north bank of the river. Part D is to calculate the surface area of the section of the river shown on the graph. In part E, a horizontal line is drawn through point P. The section of the river that is south of the line is declared a no swimming zone. Here part E is to find the area of the no swimming zone. In part F, it states that scientists observe the north bank of the river is changing over time. It is moving further north from its current position. They model its predicted new location using the function with rule u equals k multiplies f1 of x, where k is greater than or equal to 1. The question in part F is to find the values of k for which the distance north across the river for all parts of the river is strictly less than 20 meters. Now let's start with part A. In order to find the distance to get to the north bank from P towards north, the distance d equals f1 of 50 minus f2 of 50, which equals 10 meters. In part B, to find the distance to get to the north bank from P towards east, the distance d equals x2 minus x1. According to the given coordinates at point P, x1 equals 50 meters. As for x2, we need to solve the equation 20 times cosine pi x2 over 100 plus 40 equals 30. So cosine pi x2 over 100 equals negative 1 over 2, which gives pi x2 over 100 equals 2 pi over 3. So x2 equals 200 over 3, and hence the distance to get to the north bank from P towards east equals 200 over 3 minus 50, which equals 50 over 3 meters. Since part C is to find the minimum distance that the swimmer swims from point P to the north bank of the river, we assume x, y are such coordinates at the north bank. Hence the distance d equals square root of the sum of x minus 50, or in parentheses squared, plus y minus 30, or in parentheses squared, which equals square root of the sum of x minus 50, or in parentheses squared, plus 20 multiplies cosine pi x over 100 plus 40, or in parentheses squared. Differentiate the distance with respect to x and then set it to 0. Hence, with the help of CAS graphic calculator, we find the minimum distance is about 8.5 meters when x equals 54.5 meters. Since part D is to calculate the shaded area of the river, as shown in the diagram, the area A equals the integral from 0 to 200 of f1 of x minus f2 of x with respect to x, which equals the integral from 0 to 200 of 10 with respect to x, which equals 2000 meters squared. In part E, in order to find the area of no swimming zone, we need to draw a horizontal line and then find the coordinates at points A, B, and C respectively. Set both functions f1 of x and f2 of x equal 30. Then we can calculate the x coordinates at points A, B, and C. Based on the equation, 20 multiplies cosine pi x2 over 100 plus 40 equals 30. We may obtain that xa equals 200 over 3 meters, xb equals 400 over 3 meters. Based on the equation 20 multiplies cosine pi x2 over 100 plus 30 equals 30, we may calculate xc equals 150 meters. Hence, the area of no swimming zone equals the integral from 50 to 150 of 30 minus f2 of x, or in parentheses with respect to x, minus the integral from 200 over 3 to 400 over 3 of 30 minus f1 of x, or in parentheses with respect to x. After substituting f1 of x and f2 of x, we may calculate the area of no swimming zone, which approximately equals 837 meters squared. Based on the new model, as well as the requirement that the distance north across the river is less than 20 meters, it satisfies the inequality f1 of x minus f2 of x is less than 2, which is 20 multiplies k multiplies cosine pi x over 100 plus 40k minus 20 multiplies cosine pi x over 100 minus 30 is less than 20, which is simplified to 20 multiplies k minus 1, or in parentheses multiplies cosine pi x over 100 plus 10 multiplies 4k minus 3, or in parentheses is less than 20. Since the modulus of cosine pi x over 100 is less than or equal to 1, the inequality becomes 20 multiplies k minus 1, or in parentheses plus 10 multiplies 4k minus 3, or in parentheses is less than 20. Solving this inequality and considering k is greater than or equal to 1. Hence, the value range of k is greater than or equal to 1, but less than or equal to 7 over 6.
If you enjoyed this video, please give it a thumbs up and subscribe to help me make more math content like this. I will see you in the next video.